G'day and welcome. Look up at the night sky. On a clear night, far from the city lights, you can see a river of stars stretching across the heavens. That's our home, the Milky Way. It's a vast, spinning island of stars, dust, and gas. There are hundreds of billions of stars in our galaxy alone, each one a potential sun for other worlds. The scale is almost impossible to grasp. Our own solar system is just a tiny speck, a grain of sand on an endless beach, drifting within this magnificent structure. It feels permanent, doesn't it? A constant, unchanging backdrop to our lives. But our galaxy is not alone. It's just one of countless others scattered throughout the unimaginable emptiness of space. It sounds like something from a science fiction blockbuster, doesn't it? The collision of two galaxies. You might imagine a spectacular, chaotic explosion, a cosmic smash-up where stars crash into other stars, planets are obliterated, and everything is torn apart in a violent cataclysm. But the reality is something far more subtle, and in many ways, far more beautiful. The truth is, when galaxies collide, it's not so much a collision as it is a merger. It's a dance. A slow, graceful, gravitational dance that takes place over hundreds of millions, even billions of years. The distances between the stars within a galaxy are so incredibly vast that individual stars rarely, if ever, actually hit each other. To put it in perspective, if our sun were the size of a grapefruit in Sydney, the nearest star, Proxima Centauri, would be another grapefruit all the way over in Perth. The galaxy is mostly empty space. This cosmic dance isn't just something that happens to distant, anonymous galaxies in the far reaches of the universe. Our own Milky Way galaxy is currently on a collision course. Hurtling towards us at a staggering speed of about 110 kilometers per second is our nearest large neighbor, the Andromeda Galaxy. Now, there's no need to panic just yet. The collision isn't scheduled to begin for about 4.5 billion years. To put that in perspective, our own planet Earth is about 4.5 billion years old. So this grand event will unfold in a future as distant from us as the birth of our own world is in the past. What will it be like? Over millions of years, future stargazers will witness the most incredible light show imaginable. Andromeda will fill our field of view, its spiral arms and bright core a breathtaking sight. Then, as the two galaxies begin to merge, our sky will be transformed. Eventually, after a few 100 million years of this gravitational dance, the chaos will subside. The Milky Way and Andromeda will have merged completely, settling into a new, single, gigantic galaxy. Scientists have already given this future galaxy a name, Milkomeda. So we've talked about these galactic islands, these vast cities of stars. But what are they actually made of? What are the fundamental building blocks that come together to create something as magnificent as our own Milky Way? The most visible and dazzling component, of course, is the stars. Hundreds of billions or even trillions of them. These are the engines of the galaxy, the furnaces that forge heavier elements and illuminate the cosmos with their light. Surrounding the bright disk and bulge is another, much larger and more diffuse component, the galactic halo. This is a vast, spherical region of space that envelops the entire visible galaxy. It's sparsely populated with very old stars and ancient clusters of stars known as globular clusters. But the most enigmatic part of a galaxy is something we cannot see at all. We call this invisible stuff dark matter. It forms a massive, invisible scaffold around which the visible galaxy is built. Its gravitational influence the silent master of the galactic show. Beyond the stars and the unseen dark matter, galaxies are also filled with vast clouds of gas and dust. This is the interstellar medium, the raw material from which new stars are born. It might sound empty, but this medium is a dynamic and vital part of the galactic ecosystem. It is within the coldest, densest pockets of these enormous molecular clouds that gravity can finally take over, pulling the material together to ignite the fires of the next generation of stars. These stellar nurseries are regions of breathtaking beauty and intense activity. The dust component of this medium is also critically important. These tiny grains, smaller than the particles in smoke, are made of heavier elements like carbon and silicon, forged inside previous generations of stars. But it's also essential for forming planets. And at the very center of most large galaxies, including our own, lurks a monster, a supermassive black hole. These are objects of almost unimaginable density and gravity, millions or even billions of times the mass of our Sun. Now that we have a picture of what a galaxy is, it's crucial to understand that these cosmic cities are not stationary. Nothing in the universe truly is. Every galaxy is in motion, engaged in a complex and continuous dance, dictated by the gravity of everything else around it. Our own Milky Way, for instance, is spinning. Our Sun, located out in one of the spiral arms, is orbiting the galactic center at a blistering speed of about 230 kilometers per second. It takes us about 230 million years to complete just one circuit, a period of time we call a galactic year. Our Milky Way is a prominent member of a small gathering of galaxies we call the Local Group. This group contains over 50 galaxies, most of them small dwarf galaxies orbiting the larger members. The two heavyweights of our group are our Galaxy and the even larger Andromeda Galaxy. While the universe as a whole is expanding, with distant galaxy clusters moving away from us, on a local scale, gravity wins. It pulls galaxies together, overcoming the expansion of space. It is this relentless pull that makes collisions not just possible, but a common and fundamental part of how the universe changes, grows, and evolves over the eons. So why do galaxies collide? In a universe that is famously expanding, where everything seems to be rushing away from everything else, it feels a bit strange that these massive structures would ever crash. The answer is simple, yet profound: gravity. Imagine two ships on a vast expanding ocean. If they are far enough apart, the current will carry them further away from each other. But if they start close enough, their own mutual attraction, their gravity, can be strong enough to overcome that current. This process isn't random. Galaxies aren't just bumping into each other by chance in the dark. They are often born in proximity, forming within the same great filaments of the cosmic web. This web is the large-scale structure of the universe, a vast network of matter with dense intersections where galaxy clusters form. So the how of a galactic collision begins with location. Two galaxies find themselves as neighbors in the vast expanse of space. Their mutual gravity takes hold, an invisible handshake across the void. Over millions of years, this gentle pull becomes an irresistible force, accelerating them towards their shared destiny. When we think of a collision, we usually imagine a fast, violent event. A car crash, for example, happens in the blink of an eye. An asteroid impact is over in just a few minutes. But, a galactic collision operates on a timescale that is almost beyond human comprehension. The entire process, from the first gravitational whispers all the way to the final merger into a single new galaxy, can take hundreds of millions, or even over 1 billion years to unfold. It's really a process that happens in slow motion on a truly epic scale, like a feature film where each frame lasts for 1 million years. Let's return to our own future collision with Andromeda. The first touch, where the outer halos of the two galaxies begin to intermingle, is still about 4.5 billion years away. That's an immense stretch of time, roughly the entire age of our planet and solar system. After that first contact, the two galaxies won't just crash and stick together. Instead, they will pass through each other like giant ghosts, their structures distorted, but for the most part, still intact. This first pass-through alone could take a few 100 million years. When we watch simulations of galaxies colliding, what we see is the beautiful dance of the stars and the spectacular light show from the gas. But the main driver of the action, the choreographer of the entire dance, is something we cannot see at all: dark matter. As we discovered earlier, this mysterious, invisible substance makes up the vast majority of a galaxy's mass. Each galaxy sits within a massive spherical halo of dark matter, kind of like a pearl inside a much larger invisible oyster. And when galaxies collide, it is these enormous dark matter halos that interact first and most powerfully. While the individual particles of dark matter don't crash, their collective gravity creates a powerful drag, a kind of gravitational friction. This friction is what robs the galaxies of their orbital energy and momentum. Without dark matter, galactic collisions would be very different, and honestly, much rarer. The visible stars and gas alone wouldn't provide enough gravitational glue to ensure a merger. Two galaxies might just fly by each other, distorting each other a bit, but they would likely have enough speed to escape and continue on their separate ways. The collision begins not with a bang, but with a whisper, a gravitational whisper. The first touch isn't a physical impact, but the moment when the gravitational influence of one galaxy begins to seriously warp the shape of the other. This actually happens when the galaxies are still hundreds of thousands of light years apart. Gravity is a force that weakens with distance, so the side of a galaxy closer to its approaching partner feels a stronger pull than the side that is farther away. This difference in gravitational pull across the galaxy is called a tidal force. This differential pull begins to stretch the galaxies along the line connecting them. It's kind of like pulling on a piece of cosmic dough. Material, mostly stars and gas from the fragile outer disks, gets drawn out into vast, sweeping streams that can arc through space for hundreds of thousands of light years. These are the spectacular tidal tails we spoke of earlier. The formation of these tidal tails is the first visible, dramatic sign that a merger is underway. They are a galaxy's cry of distress, a beautiful scar left by the powerful gravitational encounter. After hundreds of millions of years of falling towards each other, the moment of first contact finally arrives. But, this is not a solid impact. This is the first pass-through, a moment of profound strangeness where two entire galaxies, each containing hundreds of billions of stars, begin to occupy the same volume of space. Imagine two immense swarms of bees flying through each other. From a distance, it looks like a single chaotic cloud. But up close, the individual bees mostly just fly past one another. The same is true for the stars. As the two galactic disks slice through one another, the experience from within would be surreal. For any observer on a planet, the night sky would transform into a spectacle of unimaginable beauty and chaos. A whole new river of stars, the stars of the invading galaxy, would pour into the heavens. While the stars themselves don't collide, their paths are dramatically altered. The combined gravity of the two galaxies acts like a colossal gravitational slingshot. Stars that were once in stable circular orbits are violently thrown onto new highly eccentric paths. As the two galactic cores pass each other and begin to move apart, a strange and beautiful phase of the merger unfolds. The galaxies are now fundamentally intertwined. They are connected by immense bridges of gas and stars, and trailed by the long, glowing tidal tails produced during the first pass. The antennae, or mice galaxies, are real-life examples of this post-pass-through stage, their distorted shapes painting a vivid picture of gravitational violence. From inside one of these galaxies, the view would be equally disorienting. The night sky is no longer a familiar map. The band of the Milky Way, our celestial home address, would be gone, replaced by chaotic streams and clumps of stars. And in the distance, you would see the other galaxy, the one that just passed through your own, receding but still monstrously large in the sky. This period between passes can last for a very long time, perhaps 100 or 200 million years. During this time, gravity works tirelessly to pull the two systems back together. Each pass acts to break the galaxies further, robbing them of orbital energy. With each subsequent pass, the chaos intensifies. The second and third encounters are often even more violent than the first. The galaxies are now moving slower relative to each other, which means they spend more time in close proximity. The experience for the stars within this maelstrom is a process called violent relaxation. It's a fantastic term. It describes how the rapidly changing gravitational field of the merging galaxies completely randomizes the stellar orbits. This violent relaxation is what ultimately transforms the shape of the resulting galaxy. The flat spinning disks of the original spiral galaxies are destroyed. The random three-dimensional orbits of the stars create a new shape, a huge, spheroidal or elliptical galaxy. During this churning process, the stars from both original galaxies become completely mixed. It would be impossible to tell which star originally came from the Milky Way and which came from Andromeda. They are all now citizens of a single new entity. At the center of this gravitational maelstrom lie the ultimate heavyweights, the supermassive black holes. Most large galaxies, including the Milky Way and Andromeda, have one of these monsters lurking in their core. As the two galaxies merge, their central black holes are carried along with the stellar cores, inexorably sinking towards the center of the newly forming galaxy. After the stellar components have merged, the the two supermassive black holes will find themselves orbiting each other. According to Einstein's theory of general relativity, these two orbiting behemoths will begin to radiate away their energy in the form of gravitational waves. These are ripples in the very fabric of space-time, spreading outwards at the speed of light. This is, without a doubt, the most powerful process in the entire merger. The energy lost to these gravitational waves is colossal, causing the black holes to spiral into each other faster and faster until they finally touch and merge into a single, even more massive, supermassive black hole. While the gravitational dance tears the old galaxies apart, it simultaneously triggers a spectacular wave of creation. The vast clouds of cold gas and dust are violently disturbed during the collision. As the galaxies pass through each other, these enormous gas clouds are slammed together. This compression is the critical trigger that awakens the sleeping giant of star formation on an unprecedented scale, turning the merging galaxies into a celestial fireworks display. This sudden, intense burst of star formation is known as a starburst. These are not just any stars. The conditions tend to favor the formation of very massive, hot, brilliant blue stars, which shine with incredible intensity. This frenzy of starbirth lights up the merging system, making it one of the most luminous objects in the universe. However, this starburst is a fleeting phase in the galaxy's life. The very stars that are born in this frenzy are the seeds of its end. The most massive of these new blue stars live fast and die young, exploding as brilliant supernovae in just a few million years. We've established that during a galactic merger, individual stars almost never collide. The sheer emptiness of a galaxy protects them from direct impacts. However, this doesn't mean the stars get a free ride. Their lives, or more accurately their journeys, are irrevocably altered by the gravitational chaos of the merger. A star like our Sun, currently in a stable, nearly circular orbit around the center of the Milky Way, would be thrown onto a completely new and different path. The familiar celestial neighborhood would be gone, replaced by a new set of stellar neighbors from both of the original galaxies. A small fraction of stars suffer an even more dramatic fate. During the closest passes of the galactic cores, the immense gravitational forces can act like a slingshot, accelerating some stars to incredible speeds. These hypervelocity stars are true cosmic exiles, lonely wanderers destined to drift through the void for eternity. For our own Sun and its solar system, the future merger with Andromeda poses little direct threat of destruction. While our orbit will change dramatically, the chances of being ejected from the new Milky galaxy are very small. We would become citizens of a new, larger and older-looking city of stars. At the heart of the merger, the two supermassive black holes are on their own collision course. But even before they merge, the chaos of the galactic collision provides them with a feast. The gravitational disruption funnels enormous quantities of gas and dust from the merging galaxies down towards the central region. As this huge influx of gas spirals towards a black hole, it forms a vast, searingly hot structure called an accretion disk. The friction and gravitational energy within this disk heat the material to millions of degrees, causing it to shine with an intensity that can outshine all the billions of stars in the host galaxy combined. This is the birth of an active galactic nucleus, or AGN. The galactic core becomes a quasar, the most luminous type of object in the entire universe. The merger doesn't just build a new galaxy, it switches on a cosmic blowtorch at its very heart, a beacon visible across billions of light years. This immense outflow of energy acts like a galactic supervolcano, pushing against the remaining gas in the galaxy. It can heat the gas to such high temperatures that it can no longer cool down to form stars, and it can even blow the gas out of the galaxy entirely. The feeding monster effectively cleans its own house. We've explored the grand, sweeping changes to galaxies as a whole, the fate of stars, and the cosmic fireworks of starbursts. But what about the smaller scales? What about planets orbiting those stars? What about our own home, the solar system? The answer, perhaps surprisingly, is that our little oasis would most likely remain remarkably stable and blissfully unaware of the larger chaos unfolding around it. It all comes down to a matter of scale. The forces at play in a galactic merger are immense, but within a single solar system, the gravitational grip of the parent star is overwhelmingly dominant. Think of it like being on a sturdy ship in a vast ocean storm. The ocean itself is in turmoil, with giant waves rising and falling, but on the deck of the ship, you are relatively safe. The ship as a whole is tossed around, but your immediate environment remains intact. Our solar system is that ship. The entire system, our sun, and all its planets, would be carried along on a new, chaotic trajectory through the merging galaxies. Its path would be altered, its destination changed forever. But the internal configuration, the delicate clockwork of the planets orbiting the sun, would likely proceed undisturbed, a small island of order in a sea of gravitational chaos. So if our solar system is likely to survive the merger unscathed, what would the experience be like for any life that might exist on Earth or on other worlds? Assuming humanity or some future form of life is still around in 4.5 billion years, would they even notice the galactic collision was happening? The direct physical effects on the planet itself would be negligible. The real changes would be written in the sky, a silent, slow, and spectacular transformation. The most profound change would be the view from the ground. The night sky, our window to the cosmos, would become a place of unimaginable beauty. But this spectacular view comes with a potential hazard. The intense starburst at the heart of the merger would unleash a torrent of radiation. The flurry of supernovae explosions would pepper the new galaxy with high-energy cosmic rays. A particularly close supernova could be catastrophic, potentially stripping away the ozone layer. Ultimately, the greatest threat to life on Earth in 4.5 billion years will not come from Andromeda, but from our own sun. By that distant future, our star will have evolved, becoming hotter and more luminous. The Earth's oceans will have long since boiled away, and the surface will be a scorched, uninhabitable desert. So, we have journeyed across billions of years, witnessing one of the most majestic and transformative events the universe has to offer. From the first gravitational whispers between two distant island universes, to the final violent merger of their supermassive black holes, the collision of galaxies is a story of epic proportions. It's a process that reminds us that the cosmos is not a static, eternal museum. It is a dynamic, evolving, and incredibly creative place. These collisions are not just acts of destruction, they are fundamental engines of creation and change, shaping the very fabric of the universe as we see it today. By studying these colossal events, we learn so much about the fundamental laws that govern our universe. They are the ultimate cosmic laboratories, allowing us to test our understanding of gravity, to probe the mysterious nature of dark matter, and to witness the intricate relationship between the growth of galaxies and their central black holes. The story of galactic collisions is also a story of perspective. It forces us to confront the immense timescales upon which the universe operates, yet it also connects us directly to this grand cosmic narrative. Our own Milky Way is part of this story, destined to dance with Andromeda in the distant future. Ultimately, what we are left with is a sense of profound beauty and awe. The universe is not just a collection of objects, it is a process. It is a story of birth, interaction, and rebirth, played out on a stage of unimaginable scale. The collision of galaxies is one of the most spectacular expressions of this cosmic cycle. We are incredibly fortunate to be here for a brief moment, to witness and understand a part of its magnificent story.